Hello, welcome to this week's Alteryx short tip. I want to show you a solution to a problem brought to me by one of the analysts out at THR. They had a extremely large test data set that they were trying to read into the database so that they could test some new functionality. And they ran into some errors that were very hard to diagnose and to find. And if they did find those errors in the data, they would need to edit and correct that so that they could use that entire file. The problem was, obviously, the file was too large to be edited, as well as it was very hard for them to debug and find out which records were bad. So the solution we came up with was to split that large file into multiple small pieces. And again, since they couldn't go into an editor, how are they going to do this? Well, we brought Alteryx into the plan. So for this example, I've created a smaller data set than they had. It still is in the hundreds of thousands of records range, and it runs extremely fast. So here's the input data. It is pipe delimited, as a lot of data comes from sources. So what we did is we read this in as a comma separated value file, CSV file. But you notice that the delimiter I gave it was a \n. I also need to set the file length to be pretty large so we can store lots of data. So when we look at this and run it, you see it's pretty efficient, and it actually separates it out into 10,000 record blocks. How we did this was by first adding a record ID to each record so we knew which one it was. We brought in a text input so I could define how many records to put in each block, as well as what the root file name would be for this. Use the append field so we get a data stream that had both the unseparated or textual records, the record ID, the block size, and the file root name. We then did a quick set of formulas in order to determine which block it needed to go in. First thing we did is we turned record ID into a float so we could get better precision for our calculation. And we determined which block it is with the ceiling function, which turns the integer at the greatest of the number that's calculated. So we take the float ID, divide by the block size, so anything less than a 1 will go into block 1. We then use that number in order to append onto the root name the actual block number it will be going in. In this case, we start out with we turn the block number into a string with no decimal places. We pad it to the left to 5 digits with a 0. We then trim it to make sure it's nice and clean, and then we add it to the file name root. This gives us each individual block that we need. We need to remove the fields that are not necessary to move forward. In this case, all that we need to move forward is the actual record that's coming in and the file block name that we'll be using. And then the simple solution going into our output is to again use a CSV file. We just gave it a name so it had a placeholder because we are going to be using dynamic naming. We use the /n as the delimiter. And we're going to take the file or table name from the field. It's going to change the entire file path. And we want to make sure we do not keep that field in the output. So then when we run it, we get our data broken up into 18, 19 actually, different files. Clicking on one of these brings us up in our editor. We can go ahead and turn on line numbers in this editor. And now you can see we have our header, we have records, Dropping all the way down to the bottom, we see we get 10,001, which is our 10,000 records plus our one header. So we've successfully broken this data out so that it can be edited, corrected, each individual file. Obviously, you'll want to put this data back together again or test it individually because this is a complete file, each one of these. Come back next week for our short tip when I'll show you how to put these 19 files back together again. Have a great day.